All right, troops home stretch. So this is table 3 in the manual, and also is presenting us some challenge to put into the spreadsheet. So I typed in all the stuff that's in that table. Oh yeah, before I put a screenshot, let's see where'd it go. Here we go. Excuse me. So I didn't put ruler here yet, but that's because I'm gonna need 3 versions of this, so I didn't put anything there yet, and it doesn't really matter. I guess I could put it there. So let's do that. And because Excel doesn't like 7.85 to 8.06, I made 2 lines. And then since this is not formatted as a number, when I type in 8.40, watch, let's see what happens, right? Hold it. 8.40. Yeah, you see the 0 disappears, so we have to format it as a number. There we go. All right, now, of course, this doesn't look so great. And now you're going to see also one of the reasons why I left a few spaces up above here. So we want to make all this stuff sort of, let's see if we can make it more visible. But you notice that's still kind of a lot of stuff, and it doesn't fit in there very well. So watch what we can do. We can make that row wider, or I suppose thicker, taller. And we can, let's see, we want to format it so things are in the middle. And it's a, since it, oh, that's interesting. Why did it jump like this? And since it's titles, I'll center it like that. Now, here's the other neat things. I'm just selecting those ones now. We want to click on wrap text, and then look what happens. Isn't that cool? Looks like we want to make it a little bit bigger. Yeah. Pretty nifty, huh? So let's see, I want to center that. And I guess I goofed here. And let's see. Where's that? Yeah. Oh boy. And let's see. Measurement error uncertainty. Oh, right. That's the plus minus of the. Yeah, I just could have copy pasted, but it was a little complicated, and then I want to get into it. So really, we want this to be the plus minus density. Oops. Yeah, I don't have to hit enter. I have wrapped, and this is for the measured. There we go. And I think, yep, misspelled something. All right. Let's see. So this really should be, let's see, we don't need value. I mean, that's what he has, whoever wrote that many years ago. And so we want density. And let's make this density. Yeah, let's make it a little more professional. So maybe we don't want the let's just get I like that better. We'll get rid of the parentheses, huh? Well, we have to, oh no, I just said get rid of the parentheses. I didn't say get rid of the word. And we'll make it capital. Okay, nice. So, right, so that's discrepancy is the accepted minus the measured. So we know that we have just put up steel here. So we need for the rulers, that's the first one here. And so we say that steel equals that. And also again, since we're doing it twice, that. And the discrepancy, I guess, is it the different? Let's see how they define it so nobody gets confused. So what we're trying to do is we want to see how good of an experimentalist we are. Yeah, it's the, oh, wait a minute. There. That's the, is less than, okay. We'll get back to that in a minute. Here it is. There's the discrepancy right up here. X one minus the other. And no, he's not defining it that way, but if they don't tell us, that's what we'll call it. Yep, okay. So the discrepancy is just the difference between measured and accepted, and we'll call it, we'll use the absolute value, ABS, of this minus that, and enter, and let's see, we'll fill, and then we need to put the plus minus measured value here, equals that. Yep, that's the ruler, and equals once again. Okay, now let's see how we format this. This has to be yeah, we can use 3 decimal places. Okay, so we see this is not what we would have expected. We would have expected to see, well, it's that's because this is a question of different kinds of error. So if, well, first of all, let's finish this up. And let's format this. We'll want the, and I'll discuss the results with you. All right. So that's the ruler. And, oh yeah, so let's see how we're going to do this. Right. Copy. Let's see what happens. Paste it, do everything. It didn't do the widths. How about what? Well, we just format it when we're done. And we need to do and paste. Now we need to, now we don't have, wait a minute, be careful, we do not have to, we can keep these two, but we need to clear this value. And we need to clear this value because we're going to use different ones. You can hit the delete key, I believe. Let's try it. Just select them. Delete. Yep. Delete. So this is going to be micrometer. And this is going to be calipers. You know, in some sense, it might be easier to stack them one on top of the other, so it's easier to go back and forth. You know, again, these all the tables have to be tweaked a little bit. So let's see what we can do here. So now I'm going to make them all exactly the same, and I want to just see how small I can get it. Yeah, it looks like it. Nice. So now at least I can see all of them at the same time. And of course these other ones, because you'll have filled in tables 1 and tables 2 and table 2, and let's see, cylinder number. So actually I don't know how many people did now, I forgot. So it looks like three different materials. So you have to see, so there's 1, 2, 3, there's 4 materials here, so you may not use all those, so you have to fill in here the material. So this is actually 1, and we call it steel. Okay, all right, so let's go through it again. Now we have the calipers, and we know that that's here. So we want to say that this equals that. And I'm only doing this twice because this is the steel, right? And we have to deal with these two guys. I see that stainless steel doesn't fit. Okay. I'll tweak that in a minute. And so this equals the plus minus from stainless steel, and this equals, once again, I mean steel and the calipers. Nice. And so, well, it's nice that they're all kind of the same. And so now I have to do, let's see if we can get a little bit more on here. So this is the micrometer. So that equals this one down here. And again, this one down here. And then we need to put in the plus minus. And so this equals that. And that one equals the same one again. All right. Now let's go over these results. And so let's see. I know what we're going to do. We are going to let me pause this for a minute. All right, so we are going to, let's see, insert. Now this doesn't give us a choice left or right. It always, if it only says insert, it goes to the left, right? So we are going to, let's see this. This is going to be our uncertainty. I don't want to, and minus the discrepancy. Discrepancy. Uncertainty. Okay, so that is the same thing as the plus minus. Okay, so why don't we do this? The plus minus density, yep, minus the discrepancy. Okay, so equals this minus that, and oh yeah, we can do the fill handle here. All right, now generally speaking, so this is called our figure of merit, and it tells us something about how good of a job we did. So we want to, what did we, oh yeah, we want borders. So that we're going to call FOM, the figure of merit. So, and this is something you would write up in your logbooks in your analysis section. So let's explain this. So our figure of merit, we would generally think that it would be greater than 0. So if the figure of merit is greater than 0, that means that our plus minus is larger than the difference between difference of, just give me a minute, yeah, difference between the measured and accepted. And we would basically want, and so we'd say, okay, this is cool. That means that we may have made a mistake somewhere, but we're correct within the size of our uncertainty, and so we say, okay, this is good. Whoops. This is good, but we'd have to say, all right, one thing we'd need to know is what's our percent of uncertainty. And let's do a quick calculation. Equals, let's see, the density, it's going to be the plus minus density divided by the density times 100. So 2.6%. That's not so bad. So we have a 2.6% error on our measurement. And if, so I'm going to pause for a minute. Zoom. So in fact, we're going to insert. And we're going to say this is our relative error, relative uncertainty. And that's going to be this thing I made right here. So, and we can't put percent. I don't know why it's putting that there, this hash mark before relative. And this is going to be expressed in percent. Okay, so this is going to equal the plus minus divided by the actual measurement times 100. Okay, no, it shouldn't have had any bearing on this. Let's make sure. Shouldn't have changed that, did it? No. Oh, and by the way, we can fill that. And oh yeah, because there's nothing in there yet. And well, you know what? You guys will be typing in numbers. So I remind you that you can fill. This one can be filled. This one can be filled. And the discrepancy can be you can use the fill handle. So let's say this, we typed in this one. So we just pull that down and we fill it in. Okay, so let's just get rid of these for now. All right, so this is good. And with if we have a percent, if we have a relative uncertainty that's less than, say, 10%, that would be really nice. In fact, basically, if you get any relative uncertainty less than 10%, then you're happy. Notice this is different than what you might have done in high school lab class, where you'd say the percent difference between accepted and measured. That's not what we're doing here. This is we have a certain plus minus of density, and we're expressing it as a percent there. So this is how you can compare other measurements, because you see, let me think about this for a minute. See, there's kind of different viewpoints. If this number was like 100 and plus or minus 0.2, then this would be much smaller percent error. And so you would be styling in some sense. But anyways, there's different ways of looking at it, right? And so it just gives you a handle. So you say 8.57 plus or minus 0.223. That seems pretty nice. And then, of course, the percent error says, yeah, that rocks. Okay. Because, you know, you might do, if this was like 100, 150, and you got a plus or minus of 5, you might be unhappy. But then when you do the relative and it comes out to be 0.1% or 1%, you say, oh, wow, I actually did okay. All right. Now, the problem now is that we have a figure of merit that's less than 0. And, oh, wait, let's make sure. Let me finish up. So, yeah, greater than 0 meant that our error is bigger than the difference. And that's pretty cool. Now, figure of merit less than 0, that means that our plus minus, our uncertainty, is smaller than the difference. And this isn't actually a catastrophe. So first of all, excuse me. So the first thing you want to see is that the relative error, excuse me, is less than 10%. 2, you want your figure of merit to be greater than 0. And yeah, and that means that, so this tells you did a great job measuring, and this tells you in the sense of you read off the numbers from your instruments very carefully. This tells you that you also used it properly. You put it, like in our case, you put the ruler in the right place, for example, or you read the correct numbers off of it. You may not have. So if the relative error is small, that just means that you decided that the 0.1 or 0.2 was fine. But in this case here, let's say you were moving too fast. Excuse me. In this case, it means, and you also, when you looked at the ruler and you saw you said, okay, I see the 2, and I wrote down 2. Now, if the figure of merit happened to be less than 0, that probably meant that the ruler said you measured something, and 1, 2, 3, and the measurement was here. It was here at 2. The thing you were measuring was 2, and you said, okay, and it was some little estimate in between, but you wrote down 3.2 instead of 2.2. So that's going to get you a figure of merit less than 0, because you're going to be so much bigger. Keeping in mind, you have to make sure that the discrepancy is in absolute value. So this says that you were, you judged your, if you had 2, you judged your, what's the right word? Oh yeah, you judged your measurement uncertainty properly. You judged your measurement uncertainty. So meaning that if something was between 2 lines, you figured out 0.2 or 0.3 correctly, but this somehow you used your ruler the wrong way. You made a mistake in the use of the ruler. Use of the ruler. So we call this a systematic error. There's just something in the design of the experiment, something went wrong. And this is also a question of, there's 2 things called accuracy and precision. Now look, we're going a little bit further away from things, so you don't have to worry about writing up systematic and with the rest I'm going to say. So it's an example of a systematic error, and it also addresses accuracy, accuracy, no, I don't like that, accuracy, and precision. So the accuracy is how well you got to the true number, and the precision is the number of decimal places. And it's tough to decide about accuracy. We happen to have, for us, these numbers that somebody else gave us. In the real world, it would be a little tougher, and for now, that's too much for us. Okay, so let's see. I like to, right, so we needed these 2 guys here. And I wonder, let's try something here. These are our new ones, right? So I'm going to copy and insert copied cells. Oops, because it took the handwriting as well. Ooh, let's see if we can do it a different way. Let's just, now you have to be careful here. So we'll start here from this. Copy. So we have to start up here. Yes. Shift cells to the right. Yep. All right. And then we just have to verify that it's referencing AN. Yep. Because sometimes when you copy paste things with the $ signs, that's not good. And we're going to, oops. Oh, we have to do it again. All right. Copy. And insert copied cells. Oh, I see what I did wrong. I did not put it in the, I didn't put it in the right place. There we go. insert copied cells, shift cells to the right. All right, now let's see here. So how did our, oh wow, look at that, isn't that something? Our percent error went down. Did I do something wrong here? Let's just double check. No, that's good. So see here, our relative error went down 0.29%. So now what we're seeing is that the calipers are better than the ruler. And what's our other one here? Point. So, and then the micrometer is better than the calipers. Now, something, I wondered, somehow I didn't format this one. Okay, now I shouldn't have to worry. We just move any one of these. Yep. All right, so that's good. And the, let's see, the figure of merit, they're all negative. Well, remember before we were saying how I had to make up some of the numbers, and again, no offense to the person. This is the first time we've done these things. I think what they did is they read off a wrong number somewhere. Okay, that's sweet, huh? So I'm going to stop this because it's already up to 31. And I'll get back to the things that should be in your notebooks for your final notebook, the analysis, for example. Okay.